Alright, so assuming that you did these by yourself, let's take a look at what the solutions for each of these systems of linear inequalities is. So on number 1, the first equation has a y-intercept of -2, so I'm going to graph that as -2, slope of 3, and the y, it's once everything less than that, so shade below. Okay, the bottom equation starts at 2, it has a slope of -1, it's a dashed line this time. Y is greater than, so if I start at the line, greater than is up above, and again the green part represents the solution there. Okay, over here on number 2, you can put them in slope-intercept form, or you can find the y-intercepts if you want to. Either of those methods, you could find an x-intercept. You can also find, say, the x-intercept and use the slope in order to graph each one of those lines. So this time, even though these two lines are parallel to each other, they have an overlap. It is that infinitely long region that makes like a parallelogram straight through there in green, and it's bounded by those two lines. Okay. Finally, number 3, you have again a horizontal line, and you have a V shape for the absolute value, and your solution is the triangle, the green triangle there, where they overlap each other. Okay, so one more of these. We've only looked at 2 inequalities at the same time. How about we throw in 3 of them? So whenever I have 3 inequalities, I want to graph all 3 of them and see which color they all three have in common, right? So go ahead and pause the video and try to figure that one out. Okay. Okay. So here we go. Top equation. When I graph it, it is a dashed line. I'm going to just do this by x and y-intercept. So the x-intercept is -2. The y-intercept is at -3. This is a dashed line. And then if I stick in 0, 0, 0, 0 makes that 0 is greater than -6. That is a true statement, so I'm going to shade the part with the origin in it. Okay. Middle equation. Okay. So on the middle equation, here we go. This one, the x-intercept, it's kind of a nasty number because it's 2/5, so let's find the y-intercept. The y-intercept is a -1, and then maybe use the slope. I'd add the 5 over divided by 2, so it's 5/2. So I'd find another point. This one is another dashed line, so dash that sucker in there. If I plug in the if I plug in the origin again, 0 plus 0 is 0 greater than -2. Yes, it is. So again, I shade the portion with the origin in it. So far I got the green section. Green section satisfies both of the top 2 inequalities. Okay, now I have one more. It's a horizontal one. So it starts at 5, and it's another dash one, horizontal one at 5. Y is the line. We want everything less than that. So there you go. And I want the kind of dark purpley storm cloud looking stuff. So this is the solution. It's this triangle here. So triangle is solution. And if I wanted just an example point of a solution, how about this one, which is 1, 0. 1, 0 would satisfy all 3 inequalities in that system. Okay? All right, so that about wraps it up. Solving a linear system of equations by graphing. Take a look at that picture over there. Whenever you talk about an intersection of a street, you're talking about the part of the street that they both have in common, right? And you don't want 2 cars to have a point of intersection, do you? No, that is not a good situation. Okay, number 2, classifying the system as consistent, which means they have a solution. It's either independent, which means they have one, or dependent, which they have infinitely many. It's basically the same line. Or inconsistent, they are parallel to each other and there is no solution. And then finally, solving a system of linear inequalities. You do that by graphing, and you're finding the color that all 3 of them or 2 of them have in common. So here is your assignment, of course, and I would suggest if you're in the flipped and you bring these challenge problems printed out, because it'll make it a lot easier to work on those in class, because I give you some little graphs and stuff. Okay, so see you in class.